All right, welcome to Algebra 2's Lesson B. Today we are going to talk about perimeter, area, volume, surface area, and sectors of circles. So this is another exciting geometry review. So let's get started with a couple of key terms. You guys remember that this is the radius. This is the diameter. And in fact, as long as it goes through the middle, it is 2 times the radius, because you have a radius here and a radius there. So, what are the equations for a circle that you should know? The area of a circle is pi times the radius squared. The circumference of a circle is either 2 pi r or it's pi times the diameter. Why? Because the diameter is 2 times the radius. Are we surprised? Absolutely not. I would highly encourage you, as much as is possible, just like the Bible says, as much as it depends on you, be at peace with all men. I would highly encourage you to never, ever, ever plug in 3.14 ever again for the rest of your life. To check your answers in the back of the book, you might have to, just to plug in 3.14 or plug in the little pi button on your calculator. But for any work that you turn in to me, like your tests, I would encourage you to leave it in terms of pi. Do not plug in the number, just treat it as a variable, because that is a more accurate answer to your problem. So with that said, we're going to talk about area a little bit. We already remember that the area of a rectangle is pi. Wow, it is not pi r squared. It is length times width. And we can also find the area of ugly things. So we have area of a triangle is base times height over 2. And let's go from there. So we are asked to find the area of this shape. So we have a half circle attached to a rectangle attached to a triangle. I messed that up. I never draw circles this way because I always do them wrong. There we go. That's better. Okay, so the radius of this is 2. The width is 4. This is 7. And this is 5. So how would I start this problem? Well, I'm going to start by writing out an equation, of course. Area is area of the semicircle plus area of a rectangle plus area of a triangle. I'm asking you to write it out like this because I want to see that you understand each piece and then you're working vertically down. So this equal sign should line up with every equal sign on the rest of your page. Okay? I really want to be able to see your thought process and see you show your work. So here's what we're going to do. Sorry, I was a little off camera there. The area of a half circle is the area of a circle divided by 2. So I'm going to write out the equation before ever plugging anything in. The area of a rectangle is length times width. Again, writing out the equation before plugging in. And the area of a triangle is base times height over 2. Now I can plug in, I've shown my work, and I've expressed what I know. So this is pi times 2 squared over 2. Length times width, it looks like the length is 4, and the height, we don't know. But we know that if this is 2, and this is 2, because it's the radius, then the height is 4. So instead of just writing 16, I'm going to write 4 times 4, showing my work. Next, I need the base, which it looks like if this is 7 and this is 4, this must be 3. So it looks like base is 3, height is 4, divided by 2. I'm going to cancel as much as I can. So 2 squared is 4, so I can cancel that. I can cancel 4 and 2 to make 2. Now I'm going to multiply across. So I have 2 pi. I have no other pi's here, so that's just going to hang out there. He's going to be just like, all right, cool. I'm happy. 4 times 4 is 16. 3 times 2 is 6. So this looks like 22 plus 2 pi. Anytime you have area, volume, distance, you must give units. These units are in meters, according to the problem. So this is meters squared. Box your answer. Notice that my equal signs lined up, my plus signs lined up. So each piece, I can tell where it came from on that problem. All right, this one, they want us to find the area of the shaded portion. Let's not throw shade now. So the radius of this is 4. We have 10. This is one of my favorite quiz questions, just a heads up. And this is 5 and 5. And they want this part. So everything outside of those two shapes. So what I'm going to do here is I'm going to take the big shape and I'm going to remove the two little ones. So it looks like the area shaded is the area of the big rectangle minus the area of the circle minus the area of the triangle. I have to write that out, and in fact, on your quizzes, you're going to see that I just ask you to write out the first step. This is the answer. That's it. It's the area of the whole thing minus the two shapes. From there, what's the area of the rectangle? Well, we know area of a rectangle is length times width. Area of a circle is pi r squared. Area of a triangle is base times height over 2. I want you writing out these equations. Do not just jump to the answer. You will lose many, many points. Ask the students who've come before you. They'll tell you. Length times width, 10 times 15. I'm writing out, showing my work. If I'm showing my work, you should be too. That's it, done. Pi r squared, pi, radius is 4 squared, minus base times height, 5 times 5, divided by 2. Cool, we're gonna have fractions, that's fine. 10 times 15 is 150. 4 squared is 16 pi, or times pi. 25 halves is 25 halves. So I'm gonna have to deal with this. 150, if I get a common denominator, would be 300 halves. I'm going to subtract 25 halves from that, so that's 275 minus 16 pi. Again, I need units, so I'll consult the book. Dimensions are in meters, meters squared. If you get a negative number for this, you did something wrong, right? Because there's obviously area there. All right, let's talk about volume a little bit. I know this is a big review for you guys, but you got this. So anytime we have a strange shape of our base, so let's say we have that problem that we did before. Let's see if I can draw it accurately. Oh, that's not bad. Okay, and we have our circle, we have a rectangle and a triangle. But let's say that that is actually a shape. You can look on page 11 of your book. Let's say that that's actually something that looks like this, but it's three-dimensional. If that makes sense. Like this is the top, and then it would have some depth. The way we would find the volume of this is that we would take the area of the base and multiply it by the height of our shape. Okay, so anything where it's the same shape all the way through, the equation is volume equals area of the base times height. Anytime it's like a shifted shape, so maybe you have like a circle and then it goes this way, but it's still the same shape all the way through, the equation is still area of the base times height, but this is the height. Really important. Okay, let's talk about ugly things like spheres. So a sphere, think about a basketball, baseball, maybe not a baseball because it's got the little sewing, oh my gosh, threads on it. There we go. So this is a sphere. The volume of a sphere, you just have to have these memorized by now. And if you don't, make note cards, memorize them now. 4/3 pi r cubed. The surface area of a sphere is 4 pi r squared. Okay, where this is the radius. Okay, gotta know those. Volume is always something cubed, area is always something squared. So that's how I remember it. All right, we talked about surface area. How do we find the surface area of a cylinder? So a cylinder looks like this. How do I find the surface area? Well, I know that there's a top and bottom. Those are circles, so I'm going to do 2 times pi r squared. Pi r squared would be the bottom, pi r squared would be the top, so I'm going to multiply it by 2. Then I need to add this like side part, which you've already covered, lateral surface area. For any shape like this, where it's the same shape all the way through, it's going to be the perimeter of the base times the height. So in this case, the perimeter of the base is 2 pi r, or the circumference of a circle, times the height. So that's your equation for surface area of a cylinder. This is the height, that's the radius. Plug it in and you got it. Okay, but if we have an uglier shape, we have to do more work. So for any other shape where the base isn't like nice and friendly like this, so let's try this one. Where we have a semicircle attached to a rectangle. The surface area would be, so volume would be area of the base times height. So if I found the area of the base and then the height of this object, again, there's a picture on page 15, we could do that. I believe the height is 10 feet. With surface area, I can use this equation. Since I have a bottom and a top, that's this shape, I'm going to do 2 area of the base plus the lateral surface area. So this is the surface area around the edges. Let's see, in our last class, I was able to draw this. So let's see if I can do it again. That's the shape we're looking at there. Okay, so I got the top, because I did the area of the base. I got the bottom. I got that guy. Whoa. I ruined my perfect drawing. Anyways, it's not perfect. I'm not perfect. It's okay. I need this side part. The way we find that for any shape where it's the same shape all the way through, like these are, is that we'll do the perimeter of the base times the height. So for this example, I would need 2 times the area of the base. The area of this is 5 times 6, which is 30. But I'm going to show my work. And then the area of this semicircle, which is pi r squared over 2. Plus the perimeter of the base, which looks like 5 plus 6 plus 5. Plus the circumference of this half a circle, which is 2 pi r over 2. All times the height. Woo! That was challenging, but not impossible. So let's plug in. Again, keeping our equal sign lined up, we have 2. Length times width is 30, because it's 6 times 5, plus pi r squared, so pi times 9 over 2. Ooh, we love fractions. Plus 5 plus 6 plus 5 is 16. I can cancel these 2's. My radius is 3. So I have 3 pi times the height, which is 10. From there, I'm going to multiply these out. So I get 60 plus 2 times 9 pi over 2 is 9 pi. Plus 16 times 10, which is 160, plus 3 pi times 10, which is 30 pi. Now I'm going to add like terms. So that looks like 220 plus 39 pi. Did I get it right? Hope I got it right. Oh, they plugged in pi. That's gross. Okay, we're not doing that. Finally, we need units. The book says dimensions are in feet, so I'll do feet squared. And that, ugly as it is your answer. Oh, look, it's the lesson that keeps on giving. All right, last part, and then we're done. How do I find the area of a sector of a circle? So, if this is a circle, and I wanted this piece of the circle, and I wanted to find the area of that, the equation for that is volume equals, well, if I had the whole circle, it would be, wow, not volume, area of a sector. If I wanted the area of the circle, it would be pi r squared, but I only want this piece of the pi. So I'm going to multiply by theta, which is just the angle here, divided by 360. So for example, if I wanted 1/4 of a circle, the angle would be 90 degrees. So my area would be 90 over 360 pi r squared. This simplifies down to 1/4 pi r squared because it's 1/4 of the circle. So we're just taking the whole area and multiplying it by a fraction. So this equation should be in your notes. And that, my friends, is Algebra 2, Lesson B.